Hi, my name is Catherine, and I'm doing temperature effects on air dynamics. For my first slide, I'm doing temperature effects on planes and its panels. As you guys might know, there are planes on the panel. There are panels on the plane, and they are used to slow the plane down, help it glide smoother through the air, so there's no turbulence, and so on. But there are a couple different materials the panels are made out of. As on this diagram right here, it shows a model of the airplane, and it color guided it, and it shows different colors. And if you look over to the key, it shows that, like, say, the dark blue kind of cyan looking color is carbon fiber. So that would be all the colors of that shows of the blue cyan color. For my next slide is how dense does the air have to be? Typically, a commercial aircraft, which is a plane that holds people, would fly around 38,000 and 40,000 feet in the air. This is between 5.6 and 7.6 miles, or about 9 to 12.2 miles. Any higher, and the air is too thin to hold planes that are large because they hold people. And any lower, then the air is thinner and it becomes less fuel efficient to fly there. And I have another diagram right here that shows different airplanes and what height they would be recommended to fly on. What temperature can a plane not fly in? I did my research and I found that as long as the plane fluids are kept warm and they're not cold or they're not frozen, the plane can usually operate. Sometimes it might not be able to, but it just depends. The normal temperature of the air when a plane flies is between 50 and 60 degrees Fahrenheit. So that's not too warm or too cold, just perfect for a plane. Why is the ping pong ball moving? Which that might be an odd question, but for my project, I would be using a hair dryer and a ping pong ball. And I have two different materials on the ping pong ball. One is a regular ping pong ball, and the other is a ping pong ball with tinfoil on it. So it shows one's denser and one's less dense. So you may think the ping pong ball would be moving from the temperature of the blow dryer or the hair dryer, but really it's moving because it's due to the wind. And if you might wonder why how heavy the ping pong ball is, it is 2.7 grams. So it's not heavy at all. And another question might be, what does this have to do with planes? Well, the wind is a major part of a plane, and when you're trying to levitate a ping pong ball with a hair dryer, the wind needs to blow really fast or the ping pong ball could fall. And I was practicing, and you might want to keep your wrist pretty still or it might fall. And right here I have diagrams of solids and liquids, of cold solids and hot solids, and cold liquids and hot liquids. And I also have solid, liquid, gas, 3 states of matter. Do you have any questions for me?
I have a question for you, Katie.
Yes.
When you were using the hair dryer to keep the to make the ping pong ball float, how did you figure out how to get it to float? Was there any things that you had to try or anything like that to get it to work?
So when I first tried it for my first time, I put the ping pong ball, then started the hair dryer, and the ping pong ball just flew off. So I'm like, how does that happen? So I started the hair dryer, and then I set the ping pong ball very carefully so it was spinning a little, but it wasn't like going crazy. And then it doesn't go too high; it goes about like this high, but it still stays pretty good, and it doesn't fly like it the first time. Anybody else have any questions for me? Well, I think that's it.